major embarrassment.
That would really be. Okay, we're going to, figure out what I was going to ask. Can you compare the technology of today and the technology back then and how it might compare?
Well, you have to compare it with what exists before. If you compare the technology that was used in the Manhattan Project compared with the industrial practices of the time, and some of the things already mentioned, such as the leak detector and the new products for corrosion resistance and leak tightness and the building of big, huge systems, then that technology was a big step forward. But compared to today's technology, it's primitive. It really, things are just so far beyond it that old fogies like me are just totally out of date.
I guess you talked so much about secrecy, and I really like some of your answers, and now I'm starting to think about the responsibility of not having an accident. We were talking about health.
Mm-hmm.
That would have really set the project back so much. Is that right? Isn't that kind of what the responsibility was? Do I
Yes, it could have. It could have. And in fact, one accident happened in the barrier testing facility where I was first worked at Columbia. We were working in the basement of Columbia University, and we were separating helium and carbon dioxide as a quick separation with the barrier to find a quick way to determine whether it's a good barrier or not. And we had other gases that we needed for different aspects of that, either in building the equipment or for various purposes. And we had one day, one of the people who was working in that group was kind of horsing around. You need a little relief from time to time from just running these routine test facilities, but he was carrying it a little much too far, and he knocked over a cylinder of helium gas, and it was under high pressure, very high pressure. I've forgotten what the pressure is, but it's several thousand pounds per square inch, and contrary to, well, it also had a regulator valve to bring the pressure down to pressure you can use. High pressure in the cylinder just to store that much gas, and then it used a pressure regulator to bring it down to where you could use it. But when the cylinder fell over, it broke the pressure gauge off of it, and the gas was streaming out of a nozzle that was at right angles to the axis of the cylinder. And so it would spin around and it would flip over, and here's a big, heavy iron cylinder, steel cylinder, that was maybe 4 feet high and several inches in diameter, just flailing around in the room. And we climbed on top of the equipment to keep out of its way, and no one was hurt, and there was no damage done because it was helium, which is an inert gas. But when we studied the laboratory, and all cylinders were to be chained tightly against a firm wall or a support, this was not. It was a violation. The regulator should not have been left on. It should have been valved out. So there were 2 violations on that. But the frightening, the terrifying thing was that standing beside the helium cylinder that was knocked over was a cylinder of hydrogen. And the cylinder of hydrogen would have produced a fantastic fire. It would probably have lost everyone in the room. And depending on how the hydrogen became ignited, whether there was enough hydrogen in the room before it ignited to cause an explosion, it could have destroyed a major part of the building. And this was a vital part of the Manhattan Project. So here was a near accident that could have had a very severe impact on the project.
Well, I'm glad you recall that story.
I won't forget it.
Is everything okay? Is that bug getting in there? Got a new bug. I thought it was one bug, but I guess they're just been...
It's the whole family, I think.
The whole family?
They usually come in families.
The sound was clean.
Okay. Do you remember any conflicts between management, the workers, the unions while you were there? Any stories about that?
Well, there's always a certain amount of conflict, but I think in general it was a pretty good situation, and the K-25 union people were easy to work with. My work at that time involved a lot of contact with them. I was often out in the machine shop helping them, show them what's important about this particular unusual device, or in more detail what they needed. And I'd always tell them as much as I could about what it was about, what it was for, just to create their interest. And I found that there was a very good feeling there. On the other hand, about 1947, it was time for an increase in wages, and the management was holding off on it, and it's kind of known what the situation was, and that brought about a strike. And when the workers struck, the management had to operate this big plant. And it had people all through the plant who were diddling little valves and little controls to make it work smoothly. But it's a very automatic process. And the management couldn't get around to diddle with all those valves, and it kept running, and it ran very well. It didn't need all the people. And so most of them didn't have jobs when the strike was over. That's kind of a major development that can come unexpectedly. And partly, perhaps mostly due to the management just being a little slow in responding, perhaps.
Let me straighten your tie. It's got a bit off to one side. I think it just happened. Okay, let's talk about women and women in the workforce, and what sorts of roles women played at K-25 and how were they treated?
Well, I had several women working at K-25 in the laboratory for which I was responsible. They were very good. They worked effectively. One of them eventually went to the Oak Ridge National Laboratory and had a long and rather, let's say, satisfying and productive career there as well as at K-25. So, but the women were very few technical people because there weren't so many technical technically trained women at that time. They didn't go into the sciences as much as people, as the women are today. So it was rather unusual to have a woman. I had one woman at Columbia University, or at the Nash building, as an engineer, and she was operating this big test equipment we had, and she was just a delight. And she was small, and sometimes we built equipment too big for her, but she found a way to climb up and take care of it and care for it properly. And it was then she left. Her husband was freed from the army in the end of the VE day, and went to the Panama. So she went to Panama with him, and I lost a really good employee. But so there weren't many involved in the direct system, although in the plant itself there were many women who were operators, and there were some of the people that were diddling with the valves and the controls that I mentioned earlier. But in those roles where they didn't need to have gone through a technical training, they were great.
Now let's talk about minorities and Afro-Americans or other minorities, and how are they treated?
In Oak Ridge, very badly. They mostly were confined to labor type jobs, janitorial. It's a dark period in our history here, and their housing was deplorable. It was simplistic. It was totally unacceptable from my point of view, even at the time. And it was just a shock when I discovered the housing that they had. Now there were Caucasians who were also living like that, and it was temporary for them because some of them were GIs, but the GIs that's kind of what they expected anyway, because they weren't expecting to have nice accommodations, but it was inexcusable, I think, for the federal government to provide very inadequate housing for minority peoples, and it's a shame. And that was a shock to come here too, from New York, where there wasn't the same type of isolation between blacks and whites, but they weren't black people working in Nashville either, other than just janitors. So it's a dark period in our history.
Okay, now talk about spouses in your family and what you did. Your outside activities, your life at Oak Ridge with your family. What was it like to live in the secret city, and what were some of the activities you did off hours?
Well, at first, when we first got some transportation, we enjoyed just driving around the countryside. It was so beautiful, and so different from the flat country in Nebraska where I had grown up, and so different pretty much from the Piedmont, North Carolina, where my wife had lived on a farm. So we were exploring the mountains and the lakes and enjoying this countryside very much. And then we also, as all the people worked on the project, I think, developed little groups that provided their own entertainment. Oak Ridge has, I think, the oldest playhouse in the state. It's at least a continuously operating playhouse, and very early had a civic orchestra, and many things like that developed, and clubs and different activities, and our family participated in some of that, and it was innovative. And looking back on it a few years ago, as to how those of us who worked on the Manhattan Project in New York City entertained ourselves. And it wasn't going to the plays or to the nightclubs and things that were in abundance in New York. Those things were too expensive for us. Well, first place. Second place, didn't have time. And so on Sunday nights, we often had just a group get together and play things like charades. And we thought, well, this is kind of interesting to be here in the middle of New York and entertaining yourself as you might out in dog patches, we called Oak Ridge at the time, after the Al Cap comic strip. But we found that people at Los Alamos were doing the same thing. And they were here in Oak Ridge. So there was a camaraderie that developed in the project that carried over into the social aspects. It was a good, wholesome, but quite entertaining. And it was talented people, so they could make it interesting.
Well, we are getting to the final questions, and I've got a different way of doing these. And since you're a writer, you know what I'm after. But I want, as succinct as possible now, to, let's say this is your final closure of your book about K-25, okay? And you're coming to this final summary, and it's like one paragraph, and you're going to summarize the whole thing. Describe what future generations should remember about K-25 in as succinct manner as possible.
Well, K-25, you might say, was an idea based on very limited technical data for the separation of isotopes by gaseous diffusion through a barrier. People had tried it before, but only in tiny pieces of laboratory equipment, just to perhaps obtain a little bit of different isotopic material for research purposes. There was nothing more than that to go on. And starting with that, and to envisioning a plant that would have acres of that kind of material in it, to operate continuously and for long periods of time, and produce the separation of isotopes for nuclear power or for weapons is a pretty remarkable thing. It's kind of hard to properly appreciate the vision that people like John Dunning had, or Fermi had, and Gene Booth and others. So I think that's a very exciting aspect of the whole project, and it worked very well. And there were so many skeptics that K25 was really built with more temporary structures than Y12, for example, which was another separating process. But Y12 process, electromagnetic separation, turned out to be labor intensive, and as I mentioned earlier, the K25 plant would pretty much run itself, and so there was no comparison in the cost of the two, even though people felt more certain of the electromagnetic separation, and indeed he did most of the separation for the first weapon. But K25, the gaseous diffusion process, turned out to be a good process. Now it's terribly energy intensive, and so it's doubtful that anyone will build new gaseous diffusion plants, new K25s, because the centrifuge, for instance, is a less expensive way to enrich uranium.
This is interesting question. It's massive, but if you imagine that you're going to write a book or a story or a documentary about K25, could you give me some of the key topics, like thinking about an outline or a progression of topics? And I know that's a massive question, but everyone's kind of had a different approach, and it's been really interesting and helpful. What are some of the key topics that need to be addressed if we were talking about K25?
Well, it's hard to separate what has happened as an accomplishment, starting as I just described, with very little experience of separating isotopes by gaseous diffusion, to building a plant that is of monstrous proportions, and to produce a fearsome weapon from this. But I suppose if you think about some of the new technology, as we mentioned earlier, the nanotechnology, for instance, may produce things equally striking and surprising in a very different way, but coming from a tiny bit of work and experience to some major development that at least perhaps we can't perceive, or at least I can't perceive what they will be. But I have a feeling that they're probably certain to happen. People are so ingenious and so dedicated. But in terms of our own country, it's frustrating to me that we are not training as many people as we should be, and we're not encouraging people to go into these various aspects of technology. And it's really strong base of technology, and the experience in operating equipment that goes with it that has led us to be a formidable society in the world. And I see us losing ground steadily. We're not putting as much money into the universities as we could or should. We're not starting in the early years of childhood development as we know how to do, and we tend too much, in my judgment, to try to perpetuate what we've had in the past. Drill for more oil. Well, you can't drill for more oil in this country. There isn't any place to drill for it. And I worked on a project for radioactive waste disposal when we were studying the great area of the Midwest that has deep-bedded salt. It's a nice disposal place. But so we discovered that there were thousands of holes drilled in the state of Kansas looking for oil and gas. And that's happened all over the country. And you know we're not going to find a Mideast oil supply. It just isn't going to happen. And if you, for instance, develop it's getting a little bit political, and probably shouldn't, but if we develop the ANWR, which would be maybe something like Prudhoe Bay, and it produced at its fullest capacity, right now, it would change our importation of oil from maybe 56% to 55% of the oil we use. Well, you're not going to win that way. You got to win by technology and by discipline of people, and the strong, well-educated, effective people.
Well, we have just 2 more minutes on this tape. Is there anything else that we're finished with all the questions? Anything else you want to say?
Well, I don't know. It's been a pleasure working with you.
Well, I've really found this incredibly interesting. Is there any other people that you think we definitely need to interview? I can show you some of the people we have interviewed, but suggestions of people that we definitely need to find?
Well,
you can think about it later, too.
Many of the best people are not living now, unfortunately. I know some people who could tell good stories but don't want to, and just because they don't like to sit in front of a camera and have people throw questions at them.
Well, tell them it's not painful.
But I find it okay.
Well, good. I think everyone's had such a different perspective on the story, and the more stories we get, the more likely we're going to get a clear picture of what happened.
Sure.
Well, I think we're done.